Hi there, welcome to this video where we continue taking a look at Bertrand Russell's Principles of Mathematics. In the last video I made a start on chapter 6, classes, and in this video I hope to, in fact I aim to get to the end of chapter 6 in this video. So this could be potentially quite a long video because there is quite a lot that I want to get through, but I really would like to complete this chapter really in this video. So this video is going to work in a very similar way, obviously, to the previous videos. I'm going to be reading from my copy of Principles of Mathematics, and I'm going to be stopping along the way to give some explanations as to what I think Russell is trying to say at various points and to give my interpretations. So we finished up in the last video. I got to the end of section 71, so we're going to be starting this video with section 72 and working through to the end of the chapter, which is section 79. There are a couple of paragraphs in this chapter that I don't fully understand. I can't really say that I necessarily fully understand anything in this book. But there are a couple of chapters in here which I really haven't convinced myself that I know that I really haven't satisfied myself what I think Russell is talking about. I'll mention them when we come to them. But as always, anyway, these videos they're not intended to be definitive in any way. They really are just presenting my interpretations of what I think Russell is saying in this book. Okay, so let's make a start then with section 72. So let me find the... As always, though, there is the chance that I might forget, even though I'm bringing it up on the screen, which part of the book, which section I'm talking about. Sometimes I might forget to change the page, so it would help if you got your own copy of Principles of Mathematics, whether it's a hard copy or a digital copy, just so that you can kind of keep up with what I'm saying, just in case I forget to change the page. Okay, so let's make a start then. So section 72. So we agreed in the preceding chapter that there are not different ways of denoting. So remember, chapter 5 was about denoting, and the conclusion that Russell arrived at is that there's certainly different objects which are denoted. So we've got the different denoting concepts. So we've got all, every, any, are, some, the, for example. And these all denote different objects. Okay. The question still remained, are there different ways of denoting, or is there just a single way, a single way of denoting? And really what it boils down to was that it's significant for us that there are different objects which are denoted in each case, but actually it doesn't make any difference to us whether we assume that there are different ways of denoting or whether there's just a single way. So I suppose you could play a kind of Occam's razor sort of game and just say, well, if it doesn't make any difference, then we may as well just assume that there's just the one way of denoting. So we agreed in the preceding chapter that there are not different ways of denoting. By the way, I've got toothache, so if I am stumbling a little bit more over my words today, then that's probably why. But only different kinds of denoting concepts and correspondingly different kinds of denoted objects. So the different kinds of denoting concepts are these. All corresponds to all, every, any, and so on, and they're the objects that they denote. We've discussed the kind of denoted object which constitutes a class. We have now to consider the kind of denoting concept. The consideration of classes which results from denoting concepts is more general than the extensional consideration. So I've spoken in previous videos about the extensional view of classes, which is effectively enumerating the terms of the class. So this has practical limitations, although what we'll find later on in this chapter is that Russell does consider it a purely practical limitation and not a theoretical limitation to enumerate the terms of a class. More general than the extensional consideration, and that is in two respects. In the first place, it allows what the other practically excludes, the admission of infinite classes. In the second place, it introduces the null concept of a class. But before discussing these matters, there is a purely logical point of some importance to be examined. Okay, so we have a serious issue when if we take an extensional view of classes. We have a serious problem when it comes to the null class, because the null class is, in inverted commas, the class which has no terms, but according to Russell, there is no such thing. If we take an extensional view, there is no such thing as a null class. And yet if we take an intentional view, there are null class concepts. Okay, so we don't have, and this causes a bit of a problem, because what we've seen in a previous, was it earlier in this chapter, in the last video that I made, what Russell says is we can have equal class concepts, and they all seem to refer to something which is the same in each case, and that is the class. So they're each referring to, this is why it's important that we don't identify classes with a class with a class concept, because in that case we can't have identity of classes. We can have equal classes, but we can never arrive at a satisfactory way of saying that two classes which have the same terms are actually identical. They're not if we identify the class with the class concept. So, but in the case of the null class, we've got all these null class concepts. They're all equal, but where is the thing that they are all pointing to? It's not there. Okay, the null class is not there, and this presents a bit of a problem, which Russell's going to be looking at in more detail as we go into this chapter. So continuing then, we see if U be a class concept, so if U be a class concept, is the concept all U's analyzable into two constituents, all and U, or is it a new concept defined by a certain relation to U and no more complex than U itself? We may observe to begin with that all U's is synonymous with U's, at least according to a very common use of the plural. Our question is then as to the meaning of the plural. The word all has certainly some definite meaning, but it seems highly doubtful whether it means more than the indication of a relation. All men and all numbers have in common the fact that they both have a certain relation to a class concept, namely to man. To man and number respectively. Okay, so we have man, number, these are the class concepts, and then we've got all men and all numbers. Okay, so these are the concepts of the class. So remember, we've got this distinction between class concept and concept of the class, which might seem to be splitting hairs, but it's really not. They are very different things. But it's very difficult to isolate any further element of allness which both share, unless we take as this element the mere fact that both are concepts of classes. It would seem then that all U's is not validly analysable into all and U, and that language in this case, as in some others, is a misleading guide. So we keep coming back to this, what was said right at the beginning of chapter 4 about a grammatical distinction, or let me get the page. A grammatical distinction cannot be uncritically assumed to correspond to a genuine philosophical difference. So, grammar is something that we can use to guide us. The grammar of the words that we use to represent various ideas can be used to guide us, but it's only a tool. It's only if we see we've seen plenty of examples of where we've got grammatical differences, but we don't have philosophical differences. So the same mark will apply to every, any, some, a, and the. So it seems then that there is man and all men are two different concepts, and there's this very particular relation between them. This allness, say, and same with number. Okay, is it the same relation between man and all men, and between number and all numbers? It doesn't really go into detail on that. Doesn't seem to be necessarily particularly important. Certainly not at this point. But Russell's putting it down to some particular relation that exists between the concept, the class concept, and the concept of the class. So it might perhaps be thought that a class ought to be considered not merely as a numerical conjunction of terms, but as a numerical conjunction denoted by the concept of a class. So what he's saying here is that rather than the class being considered as an object, just an object in its own right, does it have to be considered as an object which is denoted? And the fact that it's being denoted by something, does that come into the consideration of it as a class? Or can we just consider it as a class in its own right, whether it's denoted or not? And that's what we're going to be looking at. It's going to be answering in the next paragraph. So this complication, however, would serve no useful purpose, except to preserve Peano's distinction between a single term and the class whose only term it is, a distinction which is easy to grasp when the class is identified with the class concept, but which is inadmissible in our view of classes, because we're not identifying classes with the class concept. It is evident that a numerical conjunction considered as denoted is either the same entity as when not so considered. Okay, so the fact whether this class, this object, should I say, is being denoted or not being denoted doesn't make any difference. The object is still the same object. Or else is a complex of denoting together with the objects denoted. And the objects denoted is plainly what we mean by a class. With regard to infinite, do I need to change the page? With regard to infinite classes, say the class of numbers, it is to be observed that the concept all numbers, though not itself infinitely complex, yet denotes an infinitely complex object. This is the inmost secret of our power to deal with infinity. An infinitely complex concept, though there may be such, can certainly not be manipulated by the human intelligence. But infinite collections, owing to the notion of denoting, can be manipulated without introducing any concepts of infinite complexity. Throughout the discussions of infinity in later parts of the present work, this remark should be borne in mind. If it is forgotten, there is an error of magic which causes the results obtained to seem doubtful. So, the fact that we can denote infinitely complex objects, effectively using finite denoting concepts, is a great advantage to us. It allows us to symbolically manipulate these concepts of infinite complexity. It is interesting to consider, I guess, on some level, whether there are infinitely complex objects which are not capable of being denoted. And what do we make of those? Or they're not capable of being denoted by some finite denoting concept. I don't know what the answer is to that. Section 73. Great difficulties are associated with the null class and generally with the idea of nothing. So notice that the nothing is italicized there. I don't know. So I don't know if sometimes he seems to use italics to emphasize a word. Other times he uses italics to just like I've spoken about in previous videos, using either inverted commas or italics to indicate when you want to talk about the actual word effectively, the denoting concept itself, as opposed to what is being denoted. So here he's using italics. So is this nothing the denoting concept nothing, or is he just using nothing as emphasis here? I tend to towards the view that he's talking about nothing the denoting concept here. It's plain that there is such a concept as nothing. See, he uses the italics there again, and that's clearly about the concept nothing. So I think he's talking about nothing the concept in each case. And that in some sense nothing is something. In fact, the proposition nothing is not nothing is undoubtedly capable of an interpretation which makes it true, a point which gives rise to the contradictions discussed in Plato's Sophist. In symbolic logic, the null class is the class which has no terms at all, and symbolically it is quite necessary to introduce some such notion. So he's not, even though we're looking at things here from a philosophical perspective, and the conclusion that he's going to arrive at, spoiler alert, is that the null class doesn't exist. He does agree that from a symbolic perspective, we do need something to symbolize a null class, something that we call a null class. He does agree with that. We have to consider whether the contradictions which naturally arise can be avoided. It is necessary to realize in the first place that a concept may denote, although it does not denote anything. This occurs when there are propositions in which the said concept occurs, and which are not about the said concept, but all such propositions are false. So a classic example of this would be the present King of France is bald. So Russell uses this as an example in his On Denoting. Is it On Denoting? Yeah, 1905 On Denoting. The present King of France is bald. So this is not about the denoting concept, the present King of France. This is about the thing that is supposedly denoted by the denoting concept, the present King of France, but there is no such thing. There isn't any object that is denoted. So this proposition, the present King of France is bald, which is about supposedly the thing that is denoted by the denoting concept, the present King of France, it's not a meaningless proposition. It's false. Okay, so Russell's view is that when a description is used, such as the present King of France, which a denoting concept is used which doesn't denote, then any proposition about that thing that is not denoted, let's say, any such proposition will be false. Or rather, the above is a first step towards the explanation of a denoting concept which denotes nothing. It is not, however, an adequate explanation. Consider, for example, the proposition chimeras are animals, or even primes other than 2 are numbers. These propositions appear to be true, and it would seem that they are not concerned with the denoting concepts. So the denoting concepts in either case are chimeras in the first case, and even primes other than 2 in the latter case. And the propositions certainly are not about the denoting concepts. It would seem that they are not concerned with the denoting concepts, but with what these concepts denote. Yet this is impossible, for the concepts in question do not denote anything. Okay? Symbolic logic says that these concepts denote the null class, and that the propositions in question assert that the null class is contained in certain other classes. But with the strictly extensional view of classes propounded above, a class which has no terms fails to be anything at all. What is merely and solely a collection of terms cannot subsist when all the terms are removed. Thus we must either find a different interpretation of classes, or else find a method of dispensing with the null class. The above imperfect definition of a concept which denotes but does not denote anything may be amended as follows. All denoting concepts, as we saw, are derived... let me change the page, actually. All denoting concepts, as we saw, are derived from class concepts, and A is a class concept when X is an A is a propositional function. So this was in either chapter 4 or chapter 5, I can't remember. The denoting concepts associated with A will not denote anything when and only when X is an A, the propositional function, is false for all values of X. This is a complete definition of a denoting concept which does not denote anything. And in this case, we shall say that A is a null class concept and that all A's is a null concept of a class. Thus, for a system such as pianos, in which what are called classes are really class concepts, technical difficulties need not arise. But for us, a genuine logical problem remains, because remember, piano identifies classes with class concepts. So if we've got... So what we're talking about really is, when we're talking about classes, we're talking about class concepts. So if we've got null class concepts, then we have, for all intents and purposes, a null class. Or we might have many null classes, because we can have many null class concepts. They're all going to be equal, but they're not identical necessarily. But for us, because we're looking at things from a much more philosophical perspective and not a purely symbolic perspective, a genuine logical problem remains. So this next little bit here, I don't fully understand this, so I'm going to read through it, but I'm not really going to be making too many comments on it, if any. So the proposition chimeras are animals may be easily interpreted by means of formal implication, as meaning X is a chimera implies X is an animal for all values of X. But in dealing with classes, we've been assuming that propositions containing all, or any, or every, though equivalent to formal implications, were yet distinct from them, and involved ideas requiring independent treatment. Now, in the case of chimeras, it is easy to substitute the pure intentional view, according to which what is really stated is a relation of predicates. In the case in question, the adjective animal is part of the definition of the adjective chimerical, if we allow ourselves to use this word, contrary to usage, to denote the defining predicate of chimeras. But here again, it is fairly plain that we are dealing with a proposition which implies that chimeras are animals, but is not the same proposition. Indeed, in the present case, the implication is not even reciprocal. By a negation, we can give a kind of extensional interpretation. Nothing is denoted by a chimera, which is not denoted by an animal. But this is a very roundabout interpretation. On the whole, it seems most correct to reject the proposition altogether, while retaining the various other propositions that would be equivalent to it if there were chimeras. By symbolic logicians who have experienced the utility of the null class, this will be felt as a reactionary view, but I am not at present discussing what should be done in the logical calculus, where the established practice appears to me the best. But what is the philosophical truth concerning the null class? We shall say then that of the bundle of normally equivalent interpretations of logical symbolic formulae, the class of interpretations considered in the present chapter, which are dependent upon actual classes, fail where we are concerned with null class concepts, on the ground that there is no actual null class. We may now reconsider the proposition nothing is not nothing. Proposition plainly true, and yet, unless carefully handled, a source of apparently hopeless antinomies. Nothing, italicized, is a denoting concept, which denotes nothing, unitalicized, so that's the actual thing, if there is such a thing as nothing. But remember, we can have something which denotes, but which doesn't denote anything, denotes nothing, right? The concept which denotes is, of course, not nothing, i.e., it is not denoted by itself. The proposition which looks so paradoxical means no more than this. Nothing, italicized, the denoting concept, is not nothing, unitalicized, i.e., is not what itself denotes, but it by no means follows from this that there is an actual null class. Only the null class concept and the null concept of a class are to be admitted. But now a new not a technical difficulty, but now a new difficulty has to be met. The equality of class concepts, like all relations which are reflexive, symmetrical, and transitive, indicates an underlying identity, i.e., it indicates that every class concept has to some term a relation which all equal class concepts also have to that term, the term in question being different for different sets of equal class concepts, but the same for the various members of a single set of equal class concepts. So this is the class that we're talking about here. We've got our equal class concepts. They all, in Russell's view, have refer to something or have a certain relation to the same object, the class. But this fails in the case of null class concepts. We've got all our equal null class concepts, but what are they all related to? There isn't anything. Well, there isn't something in the let's take a non-null class. There is a definite something there, but in the case of the null class, there isn't something there. There isn't. So the relation seems to be different. Something breaks down in the case of the null class or null class concepts. Now, for all class concepts which are not null, this term is found in the corresponding class. But where are we to find it for null class concepts? To this question, several answers may be given, any of which may be adopted, for we now know what a class is, and we may therefore adopt as our term the class of all null class concepts, or of all null propositional functions. These are not null classes, but genuine classes. So the class of all null class concepts, or of all null propositional functions. These are not null classes. These are the genuine classes that he's talking about. And to either of them, all null class concepts have the same relation. Okay, so on the one, so let's take non-null class concepts. So we've got U, we've got V, we've got W. So these all have a particular relation to the same object, a class. So these are non-null. U, V, and W will take as meaning non-null class concepts, but equal class concepts. But they all also have evidently a relation to the class of all equal null class the class of all equal class concepts. So it's a class of equal class concepts, which correspond to a particular class. So U, V, and W all also have a relation to this. It's a different class, okay? But it's a class which okay, U, V, and W will be, I guess, members of this class, right? The class of equal class concepts. But in the case of null class concepts, So let's say we've got A, B, and C are null class concepts. There is no class there, but there is still this class of null class concepts. So A, B, and C have a particular relation to the class of null class concepts, but there is no class there. Okay, so this is the distinction that's being made here. And apparently this relation is the same. So the relation that here that U has to the class of equal class concepts and V has to, it's the same relation. So it might, I would say it's probably maybe something to do with the membership, so relation or something like that maybe. So it's the same relation in each case apparently. So if we then wish to have an entity analogous to what is elsewhere to be called a class, but corresponding to null class concepts, we shall be forced, wherever it is necessary as in counting classes, to introduce a term which is identical for equal class concepts, to substitute everywhere the class of class concepts equal to a given class concept for the class corresponding to that class concept. So to introduce a term which is identical for equal class concepts, that's the class of null class concepts, and to substitute everywhere the class of class concepts equal to a given class concept for the class corresponding to that class concept. So we can substitute in all cases on a symbolic level. We can replace, even in the case when we've got null class concepts involved, we can kind of, so that everything's uniform across the board, even when it comes to null class concepts, we can replace the class, even when it's there, with the class of equal class concepts which correspond to that class, if we want to. On a symbolic level. On a philosophical level, that it's not an identification that we're making, it's just a kind of substitution that we're making. Okay, so we're not making an identification here. The class corresponding to the class concept remains logically fundamental, so we haven't really gotten rid of it. It's still there, but need not be actually employed in our symbolism. The null class, in fact, is in some ways analogous to an irrational in arithmetic. It cannot be interpreted on the same principles as other classes, and if we wish to give an analogous interpretation elsewhere, we must substitute for classes other more complicated entities. In the present case, certain correlated classes. So what he seems to be talking about here is if any of you watching this, which I'm sure many of you will, the construction of the real numbers. So I've done some videos on my channel going through Edmund Landau's Foundations of Analysis, where he gives a very kind of typical construction of the real numbers from the natural numbers. Okay, so he starts with the natural numbers, and then he constructs fractions, and then rational numbers, and then I can't remember. He goes through various stages, so that he kind of fills in. It's almost like filling in the real number line. It's not really like, don't take that too literally, but it's kind of, we've got these natural numbers, and then he's just filling in the gaps gradually as we go along. So the natural numbers are replaced with the rational numbers, for example, at some point. Okay, so we basically we construct these. Watch the videos or read Edmund Landau's book. What I'm saying here is a very it's not a very in-depth explanation of it. So he constructs the rational numbers from the natural numbers. The rational numbers have a more complex structure to them than the natural numbers, but there are entities in the rational numbers that we can identify effectively with the natural numbers, And then we've got all of these other rational numbers besides. So we can get rid of the natural numbers and replace with this new set of objects, the rational numbers. And then from the rational numbers, we can construct the real numbers for it, or the cuts and then real numbers. Again, it's more complex structure, but within this, within the cuts, there are cuts which corresponds to what were the natural numbers, and there are cuts which corresponds to the rational numbers. But then there's these other cuts, these irrational cuts. So we can get rid of the rational numbers and we can replace them with this more complicated structure, the cuts. So that's what he's getting at here. So it's different types of objects that we're dealing with at each stage. That's what I think he's talking about when he says that the null class is kind of it's like an irrational. Okay, it's got a different structure to rational numbers. Right, it's completely different type of structure, and it has to be judged in dealt with in a different way. At least that's my interpretation of it. Right, so the null class, in fact, is in some ways analogous to an irrational in arithmetic. It cannot be interpreted on... oh, right, no, I've read that. So, the object of such a procedure will be mainly technical, but failure to understand the procedure will lead to inextricable difficulties in the interpretation of the symbolism. A very closely analogous procedure occurs constantly in mathematics, for example, with every generalization of number. And so far as I know, no single case in which it occurs has been rightly interpreted either by philosophers or by mathematicians. So many instances will meet us in the course of the present work that it is necessary to linger longer over the point at present. Only one possible misunderstanding must be guarded against. No vicious circle is involved in the above account of the null class, for the general notion of class is first laid down, is found to involve what is called existence, is then symbolically, not philosophically, replaced by the notion of class of equal class concepts, and is found in this new form to be applicable to what corresponds to null class concepts, since what corresponds is now a class which is not null. Okay, so a class exists, by the way, in Russell's understanding when it has at least one member. Okay, so on we go. Between classes simpliciter and classes of equal class concepts, there is a one-to-one correlation, which breaks down in the sole case of the class of null class concepts to which no null class corresponds, and this fact is the reason for the whole complication. Okay, so what I was talking about here, which is shown on the screen, the absence of a particular object that we can call the null class is unique to that particular case. Okay, 74. A question which is very fundamental in the philosophy of arithmetic must now be discussed in a more or less preliminary fashion. In a class which has many terms to be is a class which has many terms to be regarded as itself one or many? Taking the class as equivalent simply to the numerical conjunction A and B and C and etc., it seems plain that it is many. Yet it is quite necessary that we should be able to count classes as one each, and we do habitually speak of a class. Thus classes would seem to be one in one sense and many in another. It's worth bearing in mind what the view taken is of classes that's been described, at least classes in extension, and this word "and" that's used to connect the terms. So A and B and C and etc. This "and" it kind of glues the terms together just so much that they're not strictly many, but they're not one either. Okay, so the way that I described it in a previous video, it's kind of like some kind of boundary case or limit case between one and many. Okay, the terms considered as one is not the class. Okay, the terms considered as one is a whole. Okay, whole, WHOLE, which is different from a class. So we can have these terms that form the class, we can consider them as a whole, one object, a whole, but that is not the class. And there are certain grammatical difficulties here that seem in many ways insuperable. That even what he's getting at here is that we refer to a class, so we're referring to it as if it's one object, but in many ways the class is many, and we have to treat it as many in certain cases, because we attach number. Number is a property of classes. Okay, so we saw this with Brown and Jones. Brown and Jones are two. Okay, well, if they form one whole, then they are not two. Okay, so there must be, but they're not two separate terms either, because they're connected by this word and, Brown and Jones. So they form a certain combination where they are still effectively many, at least insofar as we're able to attach a number to them. A number doesn't necessarily mean finite number. So there is a certain temptation to identify the class as many and the class as one. Example, all men and the human race. Nevertheless, wherever a class consists of more than one term, it can be proved that no such identification is permissible. A concept of a class, if it denotes a class as one, is not the same as any concept of the class which it denotes. That is to say, classes of all rational animals, which denotes the human race as one term, is different from men, which denotes men, that's unitalicized, i.e. the human race as many. So, classes of all rational animals, well, there is only one class of rational animals. So, classes of all rational animals is denoting an object, okay, a single object. In other words, we're looking at the class of the human race as a term, one term. But men, which is the concept of the class, denotes men, the human race, as many, as a kind of plurality. Okay, so we can view a class. There's this. I've described it in a previous video, in the last video, I think, as there's this kind of tension between the one and the many when it comes to classes, and it could be viewed that Russell's really making a mountain out of a molehill with this, but this is Russell's view. Okay, that there is this tension between the two, and he finds it important to dwell upon this and to analyze this for various reasons. So continuing then, but if the human race were identical with men, it would follow that whatever denotes the one must denote the other, and the above difference would be impossible. We might be tempted to infer that Peano's distinction between a term and a class of which the said term is the only member must be maintained, at least when the term in question is a class. But it is more correct, I think, to infer an ultimate distinction between a class as many and a class as one, to hold that the many are only many and are not also one. Okay, so there is this, when he says an ultimate distinction, I don't know if he means, intends that to be some kind of indefinable concept or indefinable notion. So the class as one may be identified with the whole composed of the terms of the class. So there's an identification there. The class as one is identified with the whole, and he talks about the concepts of whole and part later in part 2. Composed of the terms of the class, i.e., in the case of men, the class as one will be the human race. But can we now avoid the contradiction always to be feared, where there is something that cannot be made a logical subject? I do not myself see any way of eliciting a precise contradiction in this case. In the case of concepts, we were dealing with what was plainly one entity. In the present case, we are dealing with a complex, essentially capable of analysis into units. So when we're dealing with class concepts, we're dealing with... I think this is what he's talking about. When we're dealing with class concepts, we effectively deal with classes. So when we're talking about classes in intention, using class concepts, we're effectively viewing classes as one. A class as one. I think that's what he's saying here. In the present case, we're dealing with a complex essentially capable of analysis into units. In such a proposition as A and B are 2, there is no logical subject. The assertion is not about A, nor about B, nor about the whole composed of both, but strictly and only about A and B. So A and B are 2 cannot be about the whole composed of both, because that would be 1. But we've seen that A and B is a particular combination of A and B. It doesn't denote A, and it doesn't denote B. It denotes A and B as a collectively, rather than distributively. Collectively, okay. So there is a unity there, but it's a very weak, evidently a very weak kind of unity. Thus, it would seem that assertions are not necessarily about single subjects, but maybe about many subjects, and this removes the contradiction which arose in the case of concepts from the impossibility of making assertions about them unless they were turned into subjects. This impossibility being here absent, the contradiction which was to be feared does not arise. We may ask, so around section 75, let me change the page. We may ask, as suggested by the above discussion, what is to be said of the objects denoted by a man, every man, some man, and any man? Are these objects one or many or neither? Grammar treats them all as one. But to this view, the natural objection is, which one? Certainly not Socrates, nor Plato, nor any other particular person. Can we conclude that no one is denoted? As well might we conclude that everyone is denoted, which in fact is true of the concept every man. So in the case of every man, we saw that in that case, every term is denoted. Okay, so if we fixate on a particular term in our collection, let's say, then we can be sure that that term is denoted by, every A. Let's take A. So we've got every A. So we've got our terms A1, A2, A3, and let's just assume there's a finite number of terms. Every A is denoted. So if we fixate on one particular term, we can be sure that that is denoted by every A. Okay, but in the case of what we're dealing with now, which is a man, every man, a, some, and any. In that case, there is some one term which is denoted, but in a distributive sort of impartial distributive sort of way. And this is quite, for me, it's quite difficult to get my head around this. I kind of get it, but it's difficult for me to visualize, so to speak. So in the case of any, one term is denoted, but whichever term we happen to fixate on, it is not that term that is denoted. And in the case of some, so some A, whichever term there is one term that is denoted, but it could be any term. Check out chapter 5 again. Some of the comments that I make, it's really, some of the distinctions are so abstract and fine, it's kind of difficult to figure it out, to get intuitively clear. So I think 1 is denoted in every case, but in an impartial, distributive manner. Any number is neither 1 nor 2 nor any other particular number, whence it is easy to conclude that any number is not any one number. A proposition at first sight contradictory, but really resulting from an ambiguity in any, and more correctly expressed by any number, italicized, is not some, italicized, one number. So any number is not some one number. There are, however, puzzles in this subject which I do not yet know how to solve. So again, we get a very fair admission from Russell here. There's a difficulty. He doesn't know what to do with it. It's fair enough, really. A logical difficulty remains in regard of the nature of the whole composed of all the terms of a class. Two propositions appear self-evident. As we'll see, they're not so self-evident. 1. Two wholes composed of different terms must be different. And 2. A whole composed of one term only is that one term. It follows that the whole composed of a class considered as one term is that class considered as one term, and is therefore identical with the whole composed of the terms of the class. But this result contradicts the first of our supposed self-evident principles. The answer in this case, however, is not difficult. The first of our principles is only universally true when all the terms composing our two wholes are simple. Okay? So a class is not necessarily a simple object. So simple in, I guess we could say it's indivisible, or it doesn't have parts. Okay? It talks about whole and part in chapter 16. I can't remember off the top of my head if he does discuss simple objects, but I would understand a simple object as a kind of object which does not have parts. So a class, generally speaking, will have parts unless it has, it's a class of one term. Okay. So if we've got a class which has more than one term, then obviously the whole, which is, if we consider the class as a whole, just the class as one considered as a whole, and the class as many considered as a whole, they're really the same thing, right? In that sense, they're not distinct, and that's because the class is not a simple. It's not a simple object. A given whole is capable, if it has more than two parts, of being analysed in a plurality of ways. So obviously if it's got two parts, it can only be analysed in one way. One part and the other part, right? But if it has more than two parts, you've got different ways of analysing it. And the resulting constituents, so long as analysis is not pushed as far as possible, will be different for different ways of analysing. This proves that different sets of constituents may constitute the same whole, and thus dispose us of our difficulty. Something must be said as to the relation of a term to a class of which it is a member, and as to the various allied relations. One of the allied relations is to be called epsilon, and is to be fundamental in symbolic logic, but it is to some extent optional which of them we take as symbolically fundamental. So the other one, which he'll talk about later, is inclusion. Okay, so we've got two relations. We've got epsilon, which is expressed as membership, and then we've got inclusion. So membership of a term in a class, and then we've got inclusion, class inclusion, which says when a class is a subclass, let's say, of another class. So we can take either of these as logically fundamental, and we can define the one in terms of the other. So Russell tends to take membership as logically fundamental. Logically, the fundamental relation is that of subject and predicate expressed in Socrates as human, a relation which, as we saw in chapter 4, is peculiar in that the relatum cannot be regarded as a term in the proposition. The first relation that grows out of this is the one expressed by Socrates has humanity, which is distinguished by the fact that here the relation is a term. Next comes Socrates is a man. This proposition, considered as a relation between Socrates and the concept man, is the one which Peano regards as fundamental, and his epsilon expresses the relation is a between Socrates and man. So long as we use class concepts for classes in our symbolism, this practice is unobjectionable. But if we give epsilon this meaning, we must not assume that two symbols representing equal class concepts both represent one and the same entity. So we talked about this earlier in this chapter. Identifying classes with class concepts presents a certain difficulty when it comes to identity of classes. We can talk about equal classes. So if we've got two classes which have the same terms, we can't necessarily infer from that they are identical. They are equal, but not necessarily identical. We may go on to the relation between Socrates and the human race, i.e. between a term and its class considered as a whole. This is expressed by Socrates belongs to the human race. This relation might equally well be represented by epsilon. It is plain that since a class, except when it has one term, is essentially many, it cannot be as such represented by a single letter. Hence, in any possible symbolic logic, the letters which do duty for classes cannot represent the classes as many, but must represent either class concepts or the wholes composed of classes, or some other allied single entities. So we've got a defect in the symbolism. The symbolism that we use to represent classes will either a given symbol will either represent the class concept or it will represent the class as one, which is this kind of conflicts a little bit with our view of classes as many. So the symbolism is kind of defective in a way that we use to represent classes, unless we are to, I guess, try to represent the class by actually stating its terms, A and B and C, but even then this is arguably a single symbol, but also it kind of defeats the object really in many ways. So typically we'll just have a single symbol, maybe a or something, uppercase A, or an alpha, for example, to represent a class, but this kind of represents the class as one. And thus epsilon cannot represent the relation of a term to its class as many. For this would be a relation of one term to many terms, not a two-term relation such as we want. This relation might be expressed by Socrates is one among men, but this in any case cannot be taken as the meaning of epsilon. Section 77. A relation which before Peano was almost universally confounded with epsilon is the relation of inclusion between classes, as example between men and mortals. This is a time-honoured relation since it occurs in the traditional form of the syllogism. It has been a battleground between intension and extension and has been so much discussed that it is astonishing how much remains to be said about it. Empiricists hold that such propositions mean an actual enumeration of the terms of the contained class, with the assertion, in each case, of membership of the containing class. They must, it is to be inferred, regard it as doubtful whether all primes are integers, since they will scarcely have the face to say that they have examined all primes one by one. So he's getting at some practical limitations here when it comes to dealing with the terms of a class one by one, or enumerating the terms of a class. You can't inspect all the terms of a class if the class is an infinite class. Their opponents have usually held, on the contrary, that what is meant is a relation of whole and part between the defining predicates, but turned in the opposite sense from the relation between the classes, i.e. the defining predicate of the larger class is part of that of the smaller. This view seems far more defensible than the other, and wherever such a relation does hold between the defining predicates, the relation of inclusion follows. But two objections may be made. First, that in some cases of inclusion there is no such relation between the defining predicates, and secondly, that in any case what is meant is a relation between the classes, not a relation of their defining predicates. The first point may be easily established by instances. The concept even prime does not contain as a constituent the concept integer between 1 and 10. The concept English king whose head was cut off does not contain the concept people who died in 1649, and so on through innumerable obvious cases. This might be met by saying that, though the relation of the defining predicate is not one of whole and part, it is one more or less analogous to implication, and is always what is really meant by propositions of inclusion. Such a view represents, I think, what is said by the better advocates of intension, and I am not concerned to deny that a relation of the kind in question does always subsist between defining predicates of classes, one of which is contained in the other. But the second of the above points remains valid as against any intentional interpretation. When we say that men are mortals, it is evident that we are saying something about men, not about the concept man or the predicate human. The question is then, what exactly are we saying? So I don't really have much to say about this, by the way, so I'm reading it just because I may as well. Peano held in earlier editions of his formulaire that what is asserted is the formal implication X is a man implies X is a mortal. This is certainly implied, but I cannot persuade myself that it is the same proposition. For in this proposition, as we saw in chapter 3, it is essential that X should take all values, and not only such as are men. But when we say all men are mortals, it seems plain that we are only speaking of men, and not of all other imaginable terms. We may, if we wish for a genuine relation of classes, regard the assertion as one of whole and part between the two classes each considered as a single term. Or we may give a still more purely extensional form to our proposition by making it mean every or any man is a mortal. This proposition raises very interesting questions in the theory of denoting, for it appears to assert an identity, yet it is plain that what is denoted by every man is different from what is denoted by a mortal. These questions, however interesting as they are, cannot be pursued here. It is only necessary to realize clearly what are the various equivalent propositions involved where one class is included in another. The foremost relevant to mathematics is certainly the one with formal implication, which will receive a fresh discussion in the following chapter. Finally, we must remember that classes are to be derived by means of the notion of such that, from other sources than subject-predicate propositions and their equivalents. Any propositional function in which a fixed assertion is made of a variable term is to be regarded, as was explained in chapter 2, and I plan to go back to the earlier chapters in some later videos, as giving rise to a class of values satisfying it. This topic requires a discussion of assertions, but one strange contradiction which necessitates the care in discrimination aimed at in the present chapter may be mentioned at once. So what he's going to go on to talk about here is the contradiction, okay? The contradiction that he's going to look at in a bit more detail in chapter 10. So section 78. Among predicates, most of the ordinary instances cannot be predicated of themselves, though by introducing negative predicates, it will be found that there are just as many instances of predicates which are predicable of themselves. One at least of these, namely predicability, or the property of being a predicative, is not negative. Predicability, as is evident, is predicable, i.e., it is a predicate of itself, but the most common instances are negative. Thus, non-humanity is non-human, and so on. The predicates which are not predicable of themselves are, therefore, only a selection from among predicates, and it is natural to suppose that they form a class having a defining predicate. Okay, so this is leading into the contradiction here. But if so, let us examine whether this defining predicate belongs to the class or not. If it belongs to the class, it is not predicable of itself, for that is the characteristic property of the class. But if it is not predicable of itself, then it does not belong to the class whose defining predicate it is, which is contrary to the hypothesis. On the other hand, if it does not belong to the class whose defining predicate it is, then it is not predicable of itself, i.e., it is one of those predicates which are not predicable of themselves, and therefore it does belong to the class whose defining predicate it is, again contrary to the hypothesis. Hence, from either hypothesis, we can deduce its contradictory. I shall return to this contradiction in chapter 10. For the present, I have introduced it merely as showing that no subtlety in distinguishing is likely to be excessive. So he gets very becomes very cautious because of this contradiction. It can seem that a lot of the stuff that he's saying can seem excessively cautious, and this extends into Principia Mathematica. So as we've seen, if you watch some of my videos on Principia Mathematica, some of it seems excessively cautious, and it's all designed in many ways to avoid this particular contradiction. So, section 79, and this will bring us to the end of this chapter. To sum up the above somewhat lengthy discussion, a class, we agreed, is essentially to be interpreted in extension. It is either a single term, or that kind of combination of terms which is indicated when terms are connected by the word and. So remember, this word and, it has to connect different terms. So A and B. So if we have something like A and A, we understand this as a meaningless expression. Okay. So the word and doesn't enter into the meaning of a class, but it does play a role in the case where we have more than one term in the class. But practically, though not theoretically, this purely extensional method can only be applied to finite classes. Okay, so it's obvious that from a practical perspective, this enumeration of terms does present a practical limitation, but what Russell is saying is that it's not a theoretical limitation, and we do need to understand classes in extension, whether they're finite or not. All classes, whether finite or infinite, can be obtained as the objects denoted by the plurals of class concepts: men, numbers, points, etc. So men, for example, he said earlier in this chapter, he uses synonymously with all men. Numbers synonymously with all numbers. Points synonymously with all points, and so on and so forth. Starting with predicates, we distinguish two kinds of proposition typified by Socrates is human, where human is the predicate. Socrates is the subject. Human is the predicate. And Socrates has humanity, where we've got a genuine relation between two terms here, Socrates and humanity, of which the first uses human as predicate, the second as a term of a relation. So human and humanity, we saw, represent the same concept. So there's, again, I've said this many times, but it's important. There's a grammatical difference there, but not a philosophical distinction. These two classes of propositions, though very important logically, are not so relevant to mathematics as their derivatives. Starting from human, we distinguished 1. The class concept man, which differs slightly, if at all, from human. Again, a grammatical difference. Is there a genuine philosophical difference there? It's kind of undecided. We'll play it safe and assume that there is, but the the similarity between the class concept man and the predicate human, it's so close that in many cases we can almost use them interchangeably. Not on a strict level we can't. We do need to make a distinction, but on a less formal level we can kind of just use them interchangeably. 2, the various denoting concepts: all men, every man, any man, a man, and some man. 3, the objects denoted by these concepts, of which the one denoted by all men was called the class as many, so that all men, italicized, the concept was called the concept of the class. 4, the class as one, i.e. the human race. We had also a classification of propositions about Socrates dependent upon the above distinctions and approximately parallel with them. 1, Socrates is a man, is nearly, if not quite, identical with Socrates has humanity. So Socrates is a man is the subject predicate form. 2, Socrates is a man. So that's the it's a propositional function. It's kind of a particular case of the propositional function. X is a man, and we've got a denoting concept there. So Socrates is a man expresses identity between Socrates and one of the terms denoted by a man. 3, Socrates is one among men, a proposition which raises difficulties owing to the plurality of men. And 4, Socrates belongs to the human race, which alone expresses a relation of an individual to its class, and as the possibility of relation requires, takes the class as one, not as many. So that's the epsilon relation. We agreed that the null class which has no terms is a fiction, though there are null class concepts. It appeared throughout that, although any symbolic treatment must work largely with class concepts and intension, classes and extension are logically more fundamental for the principles of mathematics, and this may be regarded as our main general conclusion in the present chapter. So that brings us to the end of chapter 6. The next chapter will be propositional functions, but for a while I'm going to leave it there with these. I do intend at a future date to come back, and I would like to make a set of videos that covers effectively the whole of part 1 of Principles of Mathematics. And I mean I'd like to continue further than that, potentially further down the line. It's just these videos take a while to make. I've really got to make sure that I'm familiar with the contents of the various chapters. So I've got to read through them several times to make sure that I'm fully ready to, as ready as I can be to talk about the contents of the chapters. But I would like to there are some other works that I'd like to move on to for a while at least. But I do fully intend to come back to Principles of Mathematics. It is something that I regularly come back to for one reason or another. So I'm going to leave it there with this video. As always, if there are any questions that you've got regarding the contents of this video, any of my other videos, please feel free to ask. I'd be very grateful if you would consider subscribing to the channel, hitting the like button, and leaving a nice positive comment in the comments section. If you've got any ideas about any interesting works that you think it would be worth going through on this channel, let me know. I'd be quite happy to, if I think it's going to be something that's going to be interesting to me. I'll definitely consider it. But for the time being, that's it for now. It might be a while before I upload any more videos, get my thoughts together for whatever it is that I'm going to be moving on to next. So thank you very much for watching this video, especially if you've made it right to the end. And I will look forward to seeing you in the next video.